Hi guys, welcome to the class. In this class, we are going to discuss about properties of whole numbers. See, first check the properties of whole numbers in addition. See, let's take two whole numbers, 2 and 3. Let's add these two numbers. 2 plus 3 is equals to 5. Here, 2 and 3 both are whole numbers. Now, here the result is 5. Here, 5 is also a whole number. Let's take another example. 4 plus 2. The answer is 6. Here 4 and 2 both are whole numbers. And the answer 6 is also a whole number. Now let's take another example. 4 plus 0. 4 is a whole number and 0 is a whole number. The answer is 4. So the answer is also a whole number. So we can conclude that the sum of two whole numbers results to a whole number, and we can conclude that whole numbers are closed under addition. So whole numbers are closed under addition. Now let's check in multiplication. See, let's take two whole numbers, same 2 and 3. Let's multiply these two. 2 into 3 is equals to 6. Here 2 is a whole number, 3 is a whole number, and the answer 6 is also a whole number. Now let's take 2 into 0. 2 is a whole number, 0 is a whole number. The answer is 0. 0 is also a whole number. Here we can see that multiplying two whole numbers results to a whole number. So we can say that multiplication of two whole numbers results to a whole number. See here, multiplication of two whole numbers results to a whole number. So whole numbers are closed under multiplication also. Whole numbers are closed under multiplication. See here, whole numbers are closed under multiplication and whole numbers are closed under addition. So combinedly we can write whole numbers are closed under addition and multiplication. See, here whole numbers are closed under addition and multiplication. Now let's discuss about divisible by 0. See here, let's take two numbers. So let's take a division, 6 divided by 3. Here we have to subtract 3, and from that answer we have to subtract 3, and from that answer we have to subtract 3. How many times we are going to subtract 3 from this number? Until we get 0. For suppose let's take 6 minus 3 is equals to 3. Here 3 minus 3 is equals to 0. Here this is the first step and this is the second step. How many steps we have taken? Once and first and second. So the answer is 2. 6 divided by 3 is equals to 2. Let's take another example. 8 divided by 2. See, first we have to subtract 2 from 8. 8 minus 2 is equals to 6. Now from the answer we have to subtract 2. 6 minus 2 is equals to 4. Again we have to subtract 2 from the answer. 4 minus 2 is equals to 2. Here again we have to subtract 2 from the answer. 2 minus 2 is equals to 0. How many times we have performed this subtraction? 1, 2, 3, 4. So the answer is 4. 8 divided by 2 is equals to 4. In the same way, let's take 3 divided by 0. See, we have to subtract 0 from 3. 3 minus 0 is equals to 3. And we have to subtract 0 from 3 again. 3 minus 0 is equals to 3. Again we have to subtract 0 from 3. 3 minus 0 is equals to 3. And the answer we are getting is 3, which is common. This is going to be continued. So there is no end for this pattern. And so there is no answer. So if any number is divided by 0, so the answer is not defined. If the number is divided with 0, the answer is not defined because there is no n for this pattern, and so if there is no n we can't get the answer. How many times we are going to follow this process? So we have no count, so the answer is not defined. Now let's see commutativity of whole numbers. See, for suppose let's take two numbers 2 plus 3. Here the answer we get is 5. If we do the same 3 plus 2, the answer is also 5. See, here we added 3 to 2. Here we have added 2 to 3. The pattern is changed. The number which we are adding to the other number is changed, but the two numbers are same. Two numbers are same, but the process we are adding to the other number is changed. So the answer we are getting is same. See, if we add two numbers irrespective with the order, we will get the same answer. This is called commutative property under commutative property of addition. Now if we take two numbers, now we will try with multiplication. 2 into 3, the answer is 6, and we change the order. Here we have multiplied 2 into 3. Now we will multiply 3 into 2. 3 into 2. Here the answer is also 6. See, here first we have multiplied 2 with 3. Here we have multiplied 3 with 2. But the answer is same. Here, as same in the addition, irrespective of the order, if we take two numbers and irrespective with the order, we will get the same answer. This is called commutative property under multiplication. Commutative property of multiplication. Here you got cleared my point. See, irrespective of the order, if we add the numbers or multiply the numbers, the answer is same. Now let's discuss about associative property of whole numbers. In commutativity, we have taken two numbers. In the associative, we have to take three numbers. For suppose 2, 3, 4. See, here first we add the numbers 2 plus 3 plus 4. Here first we will add first two numbers and then we will add 4. 2 plus 3 is 5 and plus 4 is, here we have to add plus 4 to the answer we have got. 5 plus 4 is 9. Now let's check in the other way. We will add first these two numbers 2 plus 3 plus 4. Here we have added first two numbers. Here we will add the second two numbers. We will add this 2 plus 3 plus 4 is 7. The answer is 9. See, irrespective of the order, whether you add first two numbers or second two numbers, the answer is same. This is the called associative property of addition. Now let's check with the multiplication. 2 into 3 into, let's take 1. See, here first we will multiply first two numbers, which is 2 into 3 is 6. Then we will multiply with 1. The answer is 6. Now in the same way, 2 into 3 into 1. Here we will multiply first second two numbers. Now 2 into 3 into 1, 3. The answer is 2 3s are 6. The answer is same. See, here also we changed the order of the multiplication. First here we have multiplied first two numbers. Here we multiplied second two numbers. But irrespective of the order, the answer we got is same. So this is called associative property of multiplication. Now let's discuss about identities. Identities. See, for suppose let's perform some addition operatives. 2 plus 3 is 5. 2 plus 0 is 2. 2 plus 4 is 6. 4 plus 0 is 4. Here identity means if we add something to a number, then we should get the same answer. See here, 2 plus 3, we got 5. Here 2 plus 0, we have got the same 2. And if we take 2 plus 4, the answer is 6. If we add 4 plus 0, the answer is 4. So, by adding 0 to some number, there is no change in the value. So, 0 is the additive identity. Now, let's check under multiplication. Let's perform some operations. 2 into 3 is equals to 6. 3 into 1 is equals to 3. 3 into 0 is equals to 0. 3 into 0 is equals to 0. 2 into 0 is equals to 0. 2 into 1 is equals to 2. See, here 2 into 3, the answer is 6. 3 into 1, 3. 3 into 0, we got 0. 2 into 0, here also we got 0. 2 into 1, we got 2. See, by multiplying with 1, the value is not changing. So, 1 is the multiplication identity. Here, we ended with the introduction part, which is properties of whole numbers. Now, let's move into the exercise. Now, let's start solving the problems of exercise 2.2. First one, give the results without actually performing the operations using the given information. Here, he gave some problems and he wants us to find the results. But without using actual operations. See, here he gave 19 into 28. We have to find the answer without performing the multiplication of two numbers. Here he gave that using the given information. Here he gave some information. 28 into 19 is equals to 532. By this way, by using this information, we have to find the results of these. See here, 28 into 19 is equals to 532. Here he asked for 19 into 28. Here he multiplied 28 with 19. Here he multiplied 19 with 28. Here the two numbers are same, but there is change in the order. This is called commutative property. Commutative property. What is commutative property? If you add or multiply two numbers, irrespective of the order, the answer is same. Here he multiplied the same two numbers, but the order is changed. So the answer is 532. Here he multiplied 1 with 47. Here 47 with 1. There is change in the order, but the two numbers are same. So the answer is same as here, 47. See, here he multiplied A with B. The answer is C. Here he multiplied B with A. The two numbers are B, A and A, but the answer will be same. So the answer is C. See here, 58 plus 42 is equals to 100. Then he asked for 42 plus 58. Here the two numbers are 58 and 42, 42 and 58. Then two numbers are same, but the addition in the order is changed. So the answer will be same, 100. Here 85 plus 0 is 85. 0 plus 85, the answer will be same, 85. A plus B is equals to D. Then B plus A is equals to how much? See here, he added A plus B. Here he added B plus A. Two numbers are same, but the order is changed. So the answer will be same. So the answer is, in the second problem, find the sum using suitable rearrangement. Here he gave some numbers and we have to find the answer by rearranging the numbers. Let's write the rearranged statement. After rearrangement, we'll swap the values, this to here and this to here. 238 plus 162 plus 695. Here we have rearranged the numbers and first we will find the value of first two numbers. 238 plus 162. 8 plus 2 is 10. 3 plus 1 is 4. 4 plus 6 is 10. 1 plus 2 is 3. 3 plus 1 is 4. So the answer is 4. 400. 400 plus 695. Now let's add 695 for 400. 695 plus 400. 5 plus 0, 5. 9 plus 0, 9. 6 plus 4, 10. So the answer is 10,095. Sorry, 1095. It is 1095. Now Let's move into the second problem. First, we have to rearrange the numbers. Let's swap the values, this 2 here and this 2. After rearrangement, the statement is 154 plus 46 plus 197 plus 203. First, let's find the value of first two numbers, and next simultaneously we find the value of second two numbers. We'll find the value of first two numbers. 154 plus 46. 4 plus 6 is 10. 5 plus 1 is 6. 6 plus 4 is 10. The answer is 200. 200 plus. Now let's find the value of second two numbers. 197 plus 203. 7 plus 3 is 10. 9 plus 1 is 10. 1 plus 1 is 2. 2 plus 2 is 4. So the answer is 400. Now let's add 200 and 400. 0, 0. 4 plus 2 is 600. So the answer is 600. Here, after rearrangement, the value of sum of these numbers is 1095. After rearrangement, the value of sum of these numbers is 600. In the third problem, find the product by suitable rearrangement. In the previous problem, we have find the sum. In this, we have to find the product of the number by rearranging the numbers. See, here he gave three numbers. We will rearrange the two numbers by swapping. See, after rearrangement, 25 into 4 into 1963. First, let's perform the multiplication of first two numbers. 25 into 4. 4 5s are 20. 4 2s are 8, 9, 10. So, the answer is 100. 100 into 1963. See, here by multiplying with 1, we will get the same answer 1963. Here we have two zeros. So, we have to add two zeros to the result. So, the answer will be 1963. We have to add two zeros. 0, 0. So, the answer is 1,96,300. Now, in this, we have to rearrange the numbers. We will rearrange middle two numbers. After rearrangement, 20 into 50 into 255 into 6. First, let's find the value of first two numbers, and we'll find the value of second two numbers, and we will find the product of two numbers at the last. The results of the two numbers at the last. First, 20 into 50. 20 into 50. 0 into 0, 0. 0 into 0, 0. 0 into 2, 0. 5 into 0, 0. 5 2s are 10. So the answer is 1000. Now, second two numbers. 255 into 6. 6 5s are 30. 6 5s are 30. Here we have 3. 30 plus 3, 33. 6 2s are 12. 12 plus 3, 15. 255 into 6. 6 2s are 12, 15. So, the answer is 1530. Here the answer is 1000. 20 into 50, the answer is 1000. Into 255 into 6, the answer is 1530. Now, let's, by multiplying with 1, the answer will be same. So, we have to add 3 zeros because the number has 3 zeros. So, the answer will be 1530. We have to add 3 zeros. So, the answer is 15,30,000. Coming to the fourth problem, find the value of following. Here, he gave some operations and we have to find the value. Here, 368 into 12 plus 18 into 368. Here, 368 is common. Here, he has used distributive property over addition. First, let's know what is distributive property. First, suppose you have 20 balls and you have arranged in the pattern in a 5 rows and 4 columns. 1, 2, 3, 4. See, here you have arranged 20 balls in 1, 2, 3, 4, 5. 5 rows and 1, 2, 3, 4. 4 columns. So, what we can write? This pattern as 5 into 4. Now, let's split this here. Now the pattern will be 1 2 3 4 1 2 3 4 plus first pattern plus second pattern 1 2 3 4 1 2 3. See, 5 into 4 pattern is splitted up and added. Here this pattern has 2 rows and 4 columns. This is written as 2 into 4. Now here this has 3 rows and 4 columns. This is written as 3 into 4. See here, 5 into 4 is equals to 2 into 4 plus 3 into 4. Okay. Now 2 into 4 is equals to 8. 3 into 4 is equals to 12. The answer is 20. See, we know 5. How can we write 5? We can write 5 as 3 plus 2 or 2 plus 3. See, 2 plus 3 into 4 is equals to 2 into 4 plus 3 into 4. 2 into 4 plus 3 into 4. See, you observe, here we have addition, here we have multiplication. The multiplication is distributed to both numbers. The operation is done in between these numbers is addition. So this is called distributive property over addition. In the both ways, 2 plus 3 into 4 we get the same answer. 2 into 4 plus 3 into 4 we will get the same answer. So this is called distributive property over addition. In the same way, here he distributed 368 over addition. How can we write this pattern? 368 into 12 plus 18. See here, 368 is distributed to both numbers. 368 into 12 plus 368 into 18. First we will find the value of 12 plus 18. 12 plus 18. 8 plus 2 is 10. 1 plus 1 plus 1 is 3. So 368 into 30. Now let's multiply this 2. 368 into, let's multiply with 3. 3. 3 8s are 24. 3 6 are 18, 19, 20. Here we have 2. 3 3s are 9, 10, 11. Here we have 1 0. So we have to add 0. So the answer is 11,040. In the same way, second problem, he distributed 439. See, 79 into 439, 4319 into 11. So we can write 79 plus 11 into 4319. The answer will be same. So first we find the value of 79 plus 11. 79 plus 11. 9 plus 1 is 10. 7, 8, 9. So the answer is 90. 90 into 4319. Now let's multiply 4319 into 9. 4319 into 9. 9 9s are 81. 9 1s are 9. 9 plus 8, 17. 9 3s are 27. 27 plus 1, 28. 9 4s are 36. 36 plus 2, 38. Here we have 0. So we have to add 0. So the answer is 388,710. So the answer is 3,88,710. Here also he used distributive property over addition. Let's move to the fifth problem. Find the product using suitable properties. Here he gave some numbers and we have to find the product by using some properties which are suitable to it. Here he gave 205 into 1989. How we can write 205? We can write 205 as 200 plus 5 into 1989. Using distributive property, we can write it as 200 into 1989 plus 5 into 1989. First, let's find the product of first two numbers and next we find the product of second two numbers and then we will add the results. First, 1989 into 200. Multiply with 2. 2 9s are 18. 8 2s are 16. 17. 18. 2 9s are 18. 19. 2 1s are 2. 3. Here we have 200. 2 zeros. So we have to add 2 zeros. So the answer is 397800 plus. Now we will find the product of 5 into 989. 1989 into 5. 5 9s are 45. 5 8s are 40, 40 plus 4, 44. 5 9s are 45, 45 plus 4, 49. 5 1s are 5, 5 plus 4, 9. So the answer is 9,945. 9,945. Now let's add these two numbers. 39780 9945. 0 plus 5, 5. 0 plus 4, 4. 9 plus 8, 9 plus 8, 17. 7 plus 1, 9 plus 1, 10. 10 plus 7, 17. 9 plus 1, 10. 3 plus 1. So the answer is 407745, which is 4,07,745. Now let's go to the second problem. Here he gave 1991 into 1005. How can we write 1005? 1000 plus 5. We can write 1005 as 1000 plus 5. Here also we use distributive property. Using distributive property, how can we write? 1000 into 1991 plus 5 into 1991. Here 1991 into 1000. So the answer will be 1991. We have to add 3 zeros, as here we have 3 zeros. 1, 2, 3. Plus, now we should find the product of 5 into 1991. 1991 into 5. 5 ones are 5. 5 nines are 45. 5 nines are 45. 45 plus 4, 49. 5 nines are 5 ones are 5. 5 plus 4, 9. So the answer is 9955. 9955. Now let's add these two numbers. 199100 plus 9955. 0 plus 5, 5. 0 plus 5, 5. 0 plus 9, 9. 9 plus 1, 10. 9 plus 1, 10. 9 plus 1, 10. The answer is 2. So the answer is 2,000,955. So the answer is 20,950,000. Let's solve the sixth problem of exercise 2.2. A milk vendor supplies 56 liters of milk in the morning and 44 liters of milk in the evening to a hostel. If the milk costs 30 rupees per liter, how much does he get per day? See, given data, how much milk is supplied in the morning? 56 liters. The milk supplied in the morning is equals to 56 liters. The milk supplied in the evening is 44 liters. The milk supplied in the evening is equals to 44 liters. See, cost of milk per each liter is 30 rupees. Cost of milk per liter is equals to 30 rupees. Now, how he asked for how much does he get per day? See, the cost he get per day is equals to morning supplied milk cost and evening supplied milk cost. So, the cost of the milk supplied in the morning is 56 into 30 and the cost of milk supplied in the evening is 44 liters into 30. So, 44 into 30. Here, 30 is distributed over addition. So, we can rewrite this as 56 plus 44 into 30. Here, 30 is distributed for 56 and 44 under addition. So, first we have to calculate this. 56 plus 44 is equals to 6 plus 4, 10. 5 plus 1, 6. 6 plus 4, 10. 100. 100 into 30 is equals to 100 into 30 is equals to 3000. So the cost he get per day is the cost he get per day is rupees 3000. In the seventh problem, Chandana and Venu purchased 12 notebooks and 10 notebooks respectively. The cost of each notebook is 15 rupees. Then how much amount should they pay to the shopkeeper? Here, Chandana has purchased 12 notebooks and Venu has purchased 10 notebooks. And the cost of each notebook is 15 rupees. So, given data, Chandana purchased how many notebooks? 12. Chandana purchased 12 notebooks and Venu purchased 10 notebooks. And the cost of each notebook is 15 rupees. Each notebook is 15 rupees. Now, how much amount should they pay to the shopkeeper? See, how much amount should they pay? They should pay the cost to the 12 notebooks and the cost to the 10 notebooks. So, they should cost that should be paid to the shopkeeper is cost paid to the shopkeeper is equals to Chandana notebooks cost plus Venus notebooks cost. Chandana notebooks cost plus Venus notebooks cost. How much should Chandana pay? Chandana cost to be paid by Chandana. Cost to be paid by Chandana is equals to she bought 12 notebooks and for each notebook the cost is 15 rupees. So 12 into 15. And cost should be paid by Venu is cost to be paid by Venu is he bought 10 notebooks and the cost of each notebook is 15. So 10 into 15. Now cost to be paid to the shopkeeper is Chandana notebooks cost plus Venus notebook cost. So it is 12 into 15 plus 10 into 15. See here 15 is distributed to 12 and 10. So we can rewrite it as 12 plus 10 into 15. Here distributive property. Here first we will find the value of 12 plus 10. 12 plus 10 is 22 into 15. Let's find the value of 22 into 15. 22 into 15. 5 2s are 10, 5 2s are 10, 10 plus 1, 11, 1 2s are 2, 1 2s are 2. The answer is 330. So, the answer is 330. So, they should both pay to the shopkeeper. The amount to be paid to the shopkeeper is the amount to be paid shopkeeper is equals to 330 rupees.